In this video, I'm going to show you how to calculate unknown angles in simple right-angled triangles using trigonometry, using SOHCAHTOA. So if we had a triangle, something like this, it's got a right angle, it's got an angle that we need to find, so we'll call that the x. You might know this side, 13 centimeters, and maybe you know that this side is 11 centimeters, something like that, right? So you look at that, and you will know, well, from experience, when you go a bit further, you will know this is trigonometry. We need to use SOHCAHTOA. And it's no different to finding sides in the beginning, in the early stages. You still HOA, ring, SOHCAHTOA, form an equation. It's not until that point that you actually do something different. So let's start labeling. H, longest side, opposite the right angle. O, opposite the angle in the question. The angle in the question in this case is the x, the angle that we need to find. O. A is just the other side. Now we do the ring, so ring the two sides that are involved. So that's the 13 because we're going to use it, and that's the 11 because we're going to use it. Right, so SOH, you've got your SOHCAHTOA. You need to decide which one of these words involves an O and an H, and you can see it's SO. SO means sine, and it means sine angle equals O over H. Sine angle equals O over H. You don't need to write that, but you really should write this next bit. So sine angle, sine, the angle is X, equals O, the O is 11, over H, H is 13. Right, so now we formed an equation. Now this is where it's different. So basically, if you can remember, whenever you're finding an angle, you need to use your inverse trig function. So I'm just going to write it down, then I'll explain it. X is going to equal inverse sine, sine minus 1 of 11 over 13. Now as you go further through the course, you will recognize this as inverse function notation. What it just kind of does the opposite, it goes backwards. It finds an input from an output. But right now, you just need to know when you're finding an angle, you need to get this, use this inverse, and the way you get to it is by pressing shift sign. So I'm going to go to my calculator and I'm going to press shift sign. You can see it's come up like that, and then I'm going to, with a bracket, make it say 11 over 13. But just remember, whenever you're finding an angle, you need to do the inverse. You need to do the shift. So shift sine, shift cos, shift tan. And that doesn't look very sensible, and I'm quite pleased that happened. It doesn't look reasonable for that to be 1. My calculator is in the wrong mode, so if that happens to you in an exam, do recognise that, because don't forget, when it's in an exam, I'm going to come up and I'm going to reset your calculator. So when that, I need to go back, shift menu, and I need to realise that I'm in radian mode, which I probably should have realised before, but it is a good teaching point. And I need to change the radians to degrees, and then I go back, do the calculation again. So shift sign 11 over 13. And that looks a lot more likely, 57.8 degrees. So whilst I probably should have checked that, it's really one of the most important things you can learn is always check your answers if they look reasonable. That 1.008 clearly looks ridiculous. I mean, imagine what a 1 degree angle would actually look like. You wouldn't even be able to see it. Okay, we'll do one more. We'll do a cos. So a nice triangle. Okay, so say we know this, or so we want to know this, that can be the x, and this can be 7 centimeters, and this one here is a bit bigger, that can be 10 centimeters, something like that, right? So you look at it, so it's trigonometry, you need to find an angle, there's a right angle in the triangle, got two sides, need an angle, definitely SOHCAHTOA, definitely trigonometry, so we begin. HOA. H, longest side, opposite the right angle. O, opposite the angle in the question, that's the x, what we need to find. O, A, the other one. Ring, which two sides are involved? Either we need to find them, which is neither in this case, or we have them and we're going to use them as information. So the 7 and the 10 are both on size. This side, we haven't been asked to find it and we don't know its value, so it's not really involved. Okay, AH, remember SOCA tower, we need to decide which one of these it is, and you can see it's K, that has an A and an H in. K means cos, that means cos, and cos means cos angle. Remember, you don't have to write this, but I'll write it to hopefully help. Equal A over H. Adjacent side over the hypotenuse side. So now I can rewrite this equation using actual specifics. So cos x equals A. The A is 7 over H is 10. Okay, so we get to there, and now we're going to need the inverse function. Remember, to find an angle, use your inverse, shift cos. So it's going to be x equals inverse cos of 7 over 10. And now my calculator's in the right mode. I should be able to get the answer first time. So shift cos, that's 7 over 10. And that is 45.57, just three significant figures, 45.6. I say three significant figures, but actually for an angle in degrees, it's really one decimal place is more likely. You often it's not crucial anyway, but you should. I reckon one decimal place for angles, two decimal places for money, and three significant figures for just about anything else, unless you're instructed to do otherwise. So 45.6 degrees. Oh, one other thing to say: if ever you're using sine or cos, it's often you might get these mixed up, the O and the H. Sine and cos will always register an error if you try to divide, if your numerator is bigger. So say I had done 13 over 11 by accident, it would have come up with an error, and that will work for sine and cos. It won't work for tan. But just remember, if you're confused with the order, just remember it always goes from left to right. Sine equals O over H, not the other way around. Cos equals A over H. Tan angle equals O over A.